Hello student, how are you? Today I am here to explain you complex number. We have already in the previous classes I have already mentioned you about the different topics related to complex number, like to express in the form of a plus ib, quality of complex number, different algebraic properties, modulus of complex number, amplitude, polar form. Almost everything I had covered already, but I want to give you some revision of some very important questions related to the mix-up properties of complex number. So let us start. Number one is to simplify 1 plus I whole to the power 4 into 1 plus 1 by I whole to the power 4. This is about 2 marks question, you can say. So start now. Solution. You see 1 plus I whole to the power 4. You always try to make the denominator real. So 1 plus, what we will write here? I by I square whole to the power 4. Multiply both the numerator by I. Then what we will get? 1 plus I whole square. This is 1. I square, minus 1. Plus minus I. Okay. Whole to the power 4. So we can write 1 plus I into 1 minus I whole to the power 4. So this will give you 1 minus I square whole to the power 4. I square is minus 1, so minus 1 plus 1 whole to the power 4, 2 to the power 4, and 16 is the answer. Okay. So this is 2 marks sum only. Then next number 2. Question number 2 is we need to find the smallest positive integer n such that 1 plus I whole to the power twice n is equal to 1 minus I whole to the power twice n. So start the solution. We can divide both sides by 1 minus I whole to the power twice n. This will become 1 plus I whole to the power twice n by 1 minus I whole to the power twice n. This side obviously will get 1. Now actually question is this, we need to find the smallest positive integral value of n such that value of this expression is equal to 1. So start now. We can write 1 plus I by 1 minus I whole to the power twice n is equal to 1. Now make the denominator real. So you need to multiply with 1 plus I. So what will be here? 1 plus I whole square. When you will multiply denominator by 1 plus I, a minus b into a plus b, we will get a square minus b square. Okay. And whole to the power twice n is equal to 1. So now a plus b whole square. A square plus b square plus twice ab by 1 I square minus plus 1 whole to the power twice n is equal to 1. So implies 1 I square is minus 1 plus twice I by 2 whole to the power twice n is equal to 1. So actually plus 1 minus 1 to cancel only. So what you will get? Twice I by 2 whole to the power twice n equal to 1. That will give you I to the power twice n is equal to 1. Now for what positive integral, smallest positive integral value of n, I to the power twice n will be 1, that we need to find n. So try only for n equal to 1, positive integral value will take. So first is 1 obviously. Then I to the power twice n equal to I to the power 2 into 1, n equal to 1 is equal to I to the power 2, which is minus 1, it is not plus 1, okay. Then for n equal to 2, I to the power twice n equal to I to the power 2 into 2 equal to I to the power 4 equal to I square whole square minus 1 whole square. Now we have taken, if we have taken n equal to 2, then we have got this equal to 1. Therefore required positive in small, required a smallest positive integral value of n equal to 2. Okay, for n equal to 2, this equality will hold true. I think understood. Next number now. These are important sum for all your exams and tests, whether it is unit test or half-yearly or annual, which is for class 10 and in some cases to class 11 also. Now go to next sum, number 3. The question is given x equal to 3 plus 4i, 3 plus 4i, y equal to 3 minus 4i. We need to find the value of x square minus twice xy plus y square by 2 into x square plus xy plus y square. This is given. We need to find the value of this. So in this type of sum, we have already discussed that we need to find the value first x plus y and then x into y. So find x plus y equal to 3 plus 4i plus 3 minus 4i is equal to 6. You will get, will cancel. Then x into y equal to 3 plus 4i into 3 minus 4i. So how much you will get? A square minus b square, 3 square is 9 minus 16i square. So 9 plus 16i square minus 1 to 25. Now this x square minus, question is not twice xy, this is xy. X square minus xy plus y square by 2 into x square plus xy plus y square. Write down this x square plus twice xy plus y square. It was minus xy. We have written twice, I have written twice xy here. Then what we will write here? Minus 3xy, because plus 2xy minus 3xy minus xy. Okay, and by here 2 into x square plus twice xy plus y square minus xy. Twice xy minus xy is xy. This is actually x plus y whole square minus 3xy, and this is equal to again x plus y whole square minus xy. We have the value x plus y is 6. Put the value 6 square minus 3 into xy value is 25 by 2 into again x plus y value is 6 minus 25. So this is 36 minus 75, no, by 2 into 36 minus 25. So how much will get minus? 9 here, 6 minus 3 negative, by here is it 22? 22. So this is the answer, number 3. This type of this type of many sums are there. You need to find value of different things, different algebraic expressions. So always first you will find this and then go ahead. Okay, now next number. Important sum, number 4 is given if alpha plus I beta whole to the power 1 by 3 is equal to a plus ib. Okay, this is question is given. We need to show that alpha by a plus beta by b is equal to 4 into a square minus b square. So start the solution with the given term. What is given? Alpha plus I beta whole to the power 1 by 3 equal to a plus ib. To remove the 1 by 3 power, obviously we need to do a squaring on, cubing on both sides. So we will write cubing on both sides. What we will get here? Alpha plus I beta, because this whole cube 3 cancel. And this is a plus b whole cube formula is a cube plus 3a square b, the formula 3a square b plus 3a b square plus b cube. A plus b whole cube formula is a cube plus 3a square b plus 3ab square plus b cube. Here only simplifier a cube plus I, you can write 3I a square b. What is here? I a square is minus, so this sign will minus 3ab square. Is it? What is IQ equal to? IQ equal to I square into I, and minus 1 into I, so minus I, no? This is minus IBQ. Understood? So this is AQ minus 3AB square plus I into 3A square B minus BQ. Understood? It will always try to express in the form of A plus IB. Okay. This is in the form of A plus IB. So equating real and imaginary part, equating real and imaginary parts, what will we get? Alpha equal to AQ minus 3AB square and beta equal to 3A square B minus BQ. Then find, what we are going to find? Alpha by A plus beta by B. What is alpha value? AQ minus 3AB square by A plus what is beta value? 3A square B minus BQ by B. Value of alpha and beta by A and by B. Then A is common. What we will get? A square minus 3B square by A plus B is common. What we will get? 3A square minus B square by B. So B and A cancel. When you will take common, A square will be here. No. A square plus 3A square, how much will get? 4A square, and here 4B square. 4 is common. A square minus B square. This only we have to know, no? So, okay. So this is also important question. 3 marks about. Okay. And we will go to the next sum now. Different types of sum I want to revise you, different types of. Question number, very important, sum number 5 of 3 marks. If P plus IQ is equal to alpha plus I by alpha minus I, then we need to show that alpha Q equal to 1 plus P. Very important. So start the solution. What is given? P plus IQ equal to alpha plus I by alpha minus I. So just make the denominator real. So what will get? Alpha plus I whole square. Here alpha square minus I square. Understood this? Multiply both numerator and denominator by alpha plus I. Thus it will be whole square and this. Now the formula. A square plus B square plus twice I alpha, and here what we will get? Alpha square plus 1. I square is to minus 1, no? So this is alpha square. I square is what? Minus 1 plus twice I alpha by alpha square plus 1. Expressed in the form of A plus IB. The alpha square minus 1 by alpha square plus 1 plus I into twice alpha by alpha square plus 1. Now this is P plus IQ equal to this, A plus IB form, A plus IB form. So equating real and imaginary part. Equating real and imaginary parts. What we will get? P equal to this, real part equal to real part, alpha square minus 1 by alpha square plus 1, and Q equal to this, twice alpha by alpha square plus 1. Find 1 plus P. I am writing here, okay? So 1 plus P equal to 1 plus the value of P, alpha square minus 1 by alpha square plus 1, simplify, alpha square plus 1, alpha square plus 1 plus alpha square minus 1, cancel, twice alpha square by alpha square plus 1, what will get? Alpha into twice alpha by alpha square, same thing, no? Twice alpha into alpha, twice alpha square. What is this? Alpha. And what is this? This is the value of Q. So alpha Q. Okay, we have taken 1 plus P, we have got. So therefore, alpha Q equal to 1 plus P. Clear? Start with the given part, make the method real, equate real imaginary part. Take the, you can take RHS equal to LHS. Okay, so this is one of the important again. So next sum now, next type of sum. Very important, number 6. For the complex number, numbers Z1 and Z2, we need to show that modulus, very important property of modulus, okay? Whole square plus modulus Z1 minus Z2 whole square is equal to 2 into modulus Z1 square plus modulus Z2 square. See, it can be done different way, okay? Before also we have done taking the two complex number Z1, Z2 as A plus IB, C plus ID, then simplification RHS, okay? Other way also can be done, and you should know this. You should know this property. What is the other way? You should learn to use the property of modulus. Very important property, you know. What is the important property? Modulus Z square is equal to Z into Z bar. You must practice to use all these properties. So this time we are not taking Z1 and Z2, two different complex numbers, A plus IB and C plus ID. So enjoy this method, very important method. So take the left hand side. Left hand side equal to modulus Z1 plus Z2 whole square plus modulus Z1 minus Z2 whole square. See, this can be written this. To use this property directly here, what you can write? Z1 plus Z2 into Z1 plus Z2 bar. And here Z1 minus Z2 into Z1 minus Z2 bar. Okay, understood this? Suppose this is Z. So modulus Z square equal to Z into Z bar. Z into Z bar. Modulus Z square. Now this property also you know. Z1 plus Z2 modulus can be modulus Z1 plus modulus Z2, property of the, conjugate of the sum of two complex number is equal to sum of their conjugates and difference also. So this can be separated, Z1 plus Z2 into Z1 bar plus Z2 bar, and here Z1 minus Z2 into Z1 bar minus Z2 bar. Someone may feel it difficult, but it's not difficult. Once you are in habit of using the property, it's easy. Now here, simple multiplication, so just multiply carefully. So this into this, Z1 bar plus this into this z1 z2 bar. Understood? This into this. Now again this into this. What I will write? z2 z2 z1 bar plus z2 z2 bar. Multiplication is correct. Now 4. Now simply this also z1 plus z1 into z1 bar, z1 into z1 bar plus minus z1 z2 bar, this into this. Now z2 z1 bar minus z2 z1 bar minus plus z2 z2 bar, z2 z2 bar. Okay, this is z1 z2 z1 z2 bar, this is z1 z2 bar plus this is minus. Clear? This is z2 z1 bar plus z2 z1 bar minus. Cancel. See, we can get this 2 times and this 2 times. Okay, so you can write 2 z1 z1 bar plus 2 z2 z2 bar. Okay, so 2 is common. What we will get? z1 z1 bar plus z2 z2 bar. Now if z into z bar equal to modulus z square, so z1 into z2 bar equal to what we will get? Modulus z1 square. And same thing, z into z bar, modulus z square. So z2 into z2 bar, modulus z2 square, and this is the RHS. Till we standard method, but you must practice this type of, that will help you. First time it looks difficult, but once you understood, you are okay. So these are this is one of the very important. Sometimes to it 4 marks sum also. Okay, then next number, 6 number we have done. 7. Number 7. If z equal to x plus iy and modulus twice z plus 1 is equal to modulus z plus 2, then we need to show that x square plus y square equal to 1. To start the solution, the given condition is this. So modulus twice z plus 1 is equal to modulus z plus 2. Okay, take the given condition. Now put the value of z. What we will get? Modulus 2 into x plus iy plus 1 is equal to x plus iy plus 2, implied twice x plus twice iy plus 1 is equal to, when on here a plus ib form, x plus 2 plus iy modulus. This also write in the form of a plus ib. Twice x plus 1, okay, plus I into twice y modulus is equal to x plus 2 plus I y. What is modulus of a plus I? Be under root a square plus b square. So you can write under root a square plus b square. Okay, is equal to under root x plus 2 whole square plus y square. To remove the root sign, what will write? Squaring. Okay, to remove the root sign. So root sign will remove, and a plus b whole square formula, how much will get? 4x square plus 4x plus 1 plus 4y square. And here sign will remove, what we will get? X square plus 4x plus 4 plus y square. Can we cancel 4x both sides? Okay, what is left? 4x square minus x square plus 4y square minus y square is equal to, what is here? 4, and this side minus 1. How much will it? 3x square plus 3y square equal to 3. If we take 3 is common, x square plus y square equal to 3. So we will get x square plus y square equal to 1. Sometimes this question is given like that, and so that they change. They will write that then so that z into z bar equal to 1. Same question. If here, if z equal to x